Hello everyone, I'm Prashanth. Today I'll be giving you a brief overview of my project. The topic of my project is vulnerability assessment of substation using Bayesian attack graph, guided by Professor Vaibhav Kateva, Indian Institute of Science. I would like to thank CNI for funding this project. So going ahead, we'll see what kind of substation are we looking for the cyber attacks. This is a standard architecture of the substation, which is responsible for all the power transmission and distribution across a different region. So this substation contains different devices, which are known as cyber devices, basically. So these cyber devices that are present inside the substation are responsible for the data-driven communication within it. So if there is any vulnerability that are present inside this cyber devices, the attacker might use it for exploiting the cyber nodes or the devices and get into the network. So our main aim is to find such devices and the vulnerabilities that are present inside it and give a probabilistic value of saying this is the probability that this cyber device might get compromised. And along with that, we'll be using the Bayesian attack graph model for formulating the attack paths, a standard attack paths, different kinds of attack paths that an attacker might use to exploit and compromise the targeted cyber devices. So in order to explain this, we'll consider a test network and explain with some example. Moving forward, I'll explain the framework of the architecture that we have developed. So the part of the work is contributed by Lakshmikant from RBCCTS as well. So we are creating three database that contains all the informations related to the substations and the vulnerabilities that are present inside each cyber devices. So DB1 contains the list of all cyber devices and the services that are running inside it. And DB2 contains all the vulnerabilities that are associated with each of the cyber devices. So this information is basically obtained from the MITRE database, which is open source. So once DB1 and DB2 are ready, we use the information present inside these databases to create database 3, which actually tells about how one vulnerability can cause some other vulnerability. So basically, we are using DB3 for mapping between the vulnerabilities. So once these three informations are available, we use this as an input to the substation Bayesian attack graph model for getting the probability values of a cyber device getting compromised and also to formulate the attack paths that can be used by an attacker in order to compromise the targeted nodes. So let's consider a test network. So this is a test network comprising of 10 cyber nodes and 17 vulnerabilities collectively present inside each of the cyber device. So if you consider this SSHD buffer overflow vulnerability present inside the gateway and the switch one vulnerability present inside the switch. So the edge between these two vulnerabilities says that an attacker might exploit switch one root access with a probability of 0.78 if he has already exploited buffer overflow vulnerability, which is present in the gateway. So that is what these edges are explaining. So once these information are available, we give it as an input to the Bayesian model to formulate and give a result of how the attacker can move from one vulnerability to another vulnerability and what is the probability of each vulnerability that an attacker might use it for compromising the devices. So this is the formula that we are using to calculate the edge probability between two vulnerabilities. And probability of Vj given ui is representing the probability that a node getting compromised based on the parent node's state. So let's say we are considering switch root access in switch one. So the parents of This node is remote attack on gateway and SSHD buffer overflow. So the probability of switch root access getting compromised will be depending on the parent node's states, whether they are compromised or they are not compromised. So based on this one, we will calculate a local conditional probability table for switch root access and get all the LCP values for different combinations of the parent node's compromisation level. Once this information is available, we use law of total probability to calculate and get a single value representing the probability that that a node getting compromised. So this is the simulation results that we have. Let's consider four vulnerabilities. V1 represents remote attacker, V2 represents crafted HTTP root request, and V3 represents SSHD buffer overflow, V4 represents router's root access. So we have considered these four vulnerabilities that are present in two different devices. One is gateway and the other is router. So once this information is available, these edge probabilities are obtained from the MITRE database that is actually representing what is the probability that a person can move from crafted root request to router's root access. So 0.98 is the probability that it can happen. So once this information is available, we will calculate the LCPs for each node, like for V1, V2, V3, and V4. So we will explain with respect to V4. So V4 has a parent nodes as V2 and V3. So 00011011 represents the different ways of the parent node getting compromised. V2 equals to 0, V3 equals to 0 represents both are uncompromised. If both are uncompromised, then probability of V4 getting compromised is also 0. So that is the meaning of this first row. And the second row says that if it is 0 and 1, then what is the probability that V4 is getting compromised? So in this case, V3 will help for the V4 to get compromised. So we will take the edge probability of V3 as 0.78. Similarly, if V2 is 1 and V3 is 0, we will take the edge probability of V2 as 0.98. So when both are compromised, we'll take either of them are getting compromised using the earlier formula which I showed here. Using this formula, we'll calculate either of them getting compromised. So once we have all these LCP values, that is 0, 0.78, 0.98, and 0.99, we combine all these marginal cases to get a single value saying that probability of V4, that is router's root access, getting exploited given that VIN is already compromised. What is VIN? Remote attacker. So if the remote attacker is already compromised gateway, what is the probability that router's root access can be exploited? So this is the first step in our calculation. So once this information is available, we'll be having all the nodes probability of getting exploited, which is shown in this slide. So this table represents what is the probability of each individual vulnerability getting exploited. So these are the vulnerabilities that we had considered in our test network. So once this information is available, we'll go to the attack path generation. Basically, we use DFS algorithm for formulating the different attack paths between an user defined source and a destination node. And once this information is available, we use this formula, probability of exploitability of that path, to calculate the severity of each path. So once that information is available, we get this kind of graphs that are available from a source and a destination, which is defined by a user. And we also get the number of hops and the severities that are associated with each path. So based on this table represents the source vulnerability and the destination vulnerability that is given by the user, and what is the probability of exploitability of that path. and what is the hop cone that it takes for the attacker to exploit the targeted cyber device. So this is the information that we get from the model, and this information can be used by the transmission system operator for prioritizing the attacks and providing the mitigation techniques for different kinds of attacks. So thank you.